Alright, next we want to look at the final three indeterminate forms, all of which involve exponents. 1 to the infinity doesn't exist because 1 to any power is 1. Anything to the infinity power is infinity or 0. 0 to the 0 we've already talked about. Infinity to the 0, again, non-existent. Infinity to any power is either 0 or infinity, and anything to 0 is 1 doesn't exist. These, ladies and gentlemen, are going to be solved in a similar fashion as before. We still are shooting for that 0 over 0 or infinity over infinity form. But in order to do so, we have to do something about the exponent, so we use natural log, specifically this part right here. We're going to insert an e and a natural log into each equation. We will then calculate the limit of the natural log part up here, and that'll give us this answer, and then we take e to that answer. All in all, it's not too bad, actually. Alright, our first one. The limit as x approaches infinity of 1 plus 1 over x to the x. You may remember this as one of our earlier definitions of e, so hopefully this is going to come out to equal e to the first power. Again, we're going to begin by inserting an e and a natural log into the problem. E to the, and then my limit, natural log, so e natural log would cancel out, of 1 plus 1 over x to the x. And we are allowed to do this because e and natural log are continuous functions. It allows us to work out like this. Now, why would I do that? Well, because now I can take the x that was up top and I can bring it out front like so. Now, I will tell you, ladies and gentlemen, in the homework even, I don't write the e every time. Once I do this initial step, sometimes I'll just drop the e. You just need to remember in the end, when you get your final answer, to put it back with the e and have e to that power. So I now have x natural log 1 plus 1 over x. Still not in that 0 over 0 or infinity over infinity form. So if I move the x to the bottom and make it 1 over x, or x negative 1, now if I were to plug in my infinity, that would give me 0 here. Natural log of 1 is 0. 1 over infinity would be 0. Now I'm in the proper form. So I take my derivative. The derivative of all of this is this part right here. Now, let me show you how I came up with that just very quickly. This right here is the same thing as x plus 1 over x. Now, how do I get to this part right here? Quotient rule, a little bit of simplification afterwards, and so on. Alright? So, if you want to play with it, if you want me to work out how I do the derivative and come up with this simplified answer later on, I will do so. But for now, I'm just going to leave it like this. You can ask me about it in class if you can't come up with it on your own. And the derivative of x to the negative 1 is negative x to the negative second power. Now, what I do hope you'll notice is that x to the negative second negative, same thing up here, they cancel. And I have 1 over 1 plus x to the negative 1, or 1 over 1 plus x. If I were to plug in infinity right now, 1 over infinity would be 0. I end up with 1 over 1. And so I have e to the first power, which is what we knew to be true from the definition. So again, ladies and gentlemen, if you want to see all of this worked out, it's a bit of quotient rule, plus remember the derivative of natural log is the derivative over the function itself. If you want to see all that worked out and simplified, I'll be glad to do that for you at some point or another. You can just ask me about it in class tomorrow if you wish. 0 to 0. Again, we're going to work this one out the same way. We're going to insert some e's and natural logs. So I have e, limit as x approaches 0 from the right, natural log x to the x power. Bring my x out front, which I'm allowed to do so because of the natural log. Flip that x to the bottom. Now if I plug in 0, I have infinity over infinity. And that allows me now to do L'Hopital's rule. The derivative of natural log x is 1 over x. The derivative of 1 over x, if you rewrite it as x to the negative 1, is negative 1 over x squared. You can simplify all of this, and it all simplifies to be just negative x. Now if you plug in 0, you do get 0, and e to the 0 is 1. And our final problem, infinity to the 0. E natural log bring your 1 over x out front. You notice, ladies and gentlemen, it's a lot of the same kinds of steps. When you bring the 1 over x out front, it does give you this, and this already puts it in a proper form. If you plug in infinity, you have infinity over infinity. We're ready to do L'Hopital's rule. The derivative of natural log x is 1 over x. The derivative of x is 1. Plug in your infinity, you get 0 on top, 1 on the bottom. E to the 0 is 1. Ladies and gentlemen, I would expect you to have lots and lots of questions over this homework. L'Hopital's rule, while it does simplify things, some of the forms can be a little complicated. So just try what you can this evening. We'll work on it in class. And again, I apologize for the first video. Could not be helped. But I will answer any and all of your questions, as you know I always do, in class tomorrow.